Okay. Good morning, everyone. Welcome to the NRIS Best Practices and Tools for HPC episode 4. Welcome, everyone. Thank you for interest in our course. My name is Thanya Pushpadas. I'm the course coordinator of the Best Practices series. Before we start, I would like to give you some logistics. First of all, if you are new, NRIS, what is NRIS? Who are we? We are a collaboration of Norway's 4 largest universities, and which are University of Bergen, Oslo, Tromsø, and NTNU, as well as a public company, Sigma 2, who manages the national infrastructure in Norway. We collaboratively operates the national infrastructure services in Norway. So this is part of our training and outreach program. Yes, and today we will have this episode 4, which will be part 2 of the advanced shell scripting and utilities, and we will talk more about advanced set and awk. You should have received the email about the lesson material and the practicalities. One information is we use the collaborative document for asking questions, which is shared by Ule now. Which if you can edit it without logging in using the pencil icon on top of it. We have some icebreaker question to you while I give you more information. Please go through the icebreaker questions and give your answer or comments there. And another important thing is, as you can see, I am recording this event, and this will be published after reviewing and editing, and now participants' name will be shown in the published video. So if you don't want to be seen in editing, you are welcome to switch off your cameras in the Zoom, but rest assured that this will not, your names or should not be in the public video when we publish it. And I want to mention that we follow Carpentry's Code of Conduct since it is a public platform. The collaborative documents, using it, please use respectful language and don't use any sensitive information, because this will be shared during the course and afterwards also we will be sharing these documents. And this document also contains our upcoming training at NRIS and also the video recording of the previous series and links to the workshop page, etc., and links to the lesson material on top of the page. You can ask your question below. And without much ado, I would like to give the Zoom dice to Ule, who will be the instructor for today, and also welcome to introduce himself, as well as my colleague here, Espen and Maikin, who will be helping us during this course of the event. Ule, would you like to introduce yourself and give the mic to Maikin and Espen afterwards?
Right. Thank you very much for showing up for this nerdy session. It's about advanced set and awk, and the last time we went through language, some bash script, not bash script, but the variables and such, and how to manipulate the variables, and we scratch on the surface of set and awk. And if you want to review that, you can go to the recording, or you can use the markdown here as a self-page tutorial. And if you want to follow, if you want to type on or spend time later on to play it with yourself, you can download the files that you find on the downloads and educate yourself, because this is a quite deep topic. I mean, there's no end to what you can do in these magic things. I mean, just the regular expressions says it all. I mean, they are invented in the 1950s by a theoretical mathematician. So we'll go straight at it, the advanced SED. So I will be using a file called Unix hierarchy, which is a file of how people start learning using Unix. Unix was the first one that invented in the very early 70s, and then it was written by a Finnish guy, Linus, who called it Linux. And then that became the mainstream because it was free and open source and everything. And then that's taken over the world. But all the tools are still there, and many of the tools come from Richard Stallman and his open source thing, but Sedanok has been with us since the early days from Bell Labs. So we'll go straight at it. I assume, and you should be fairly familiar with grep. G is for global, RE is for regular expression, and P is for print. Many of these things come from the editor ed, which later on became VI. So you will be familiar with some of this syntax from SED, at least in VI. If you use Emacs, it's a whole different set of things, but it's doing differently. So let's see what we can just match for a pattern. I need to.
Ole, can I interrupt you?
Yeah, of course you can.
I was wondering, the video is struggling. So I'm wondering, maybe you turn off your video and just do screen sharing. Maybe it helps. What do you think, Danya? Could that be an option?
Yeah.
I've turned off my video.
Yeah, let's try and see if it's more responsive. Thanks.
Yes,
It needs
thank
to
you.
be said that I'm not at my usual office. I'm sitting here in the meeting room at Gardermoen, and I'm at the mercy of the hotel's Wi-Fi. So, yeah, I shouldn't be here, but I said you can take it from there, you can take it from there, and then I said yes to that. Maybe that wasn't the world's best idea. Anyway, we'll try.
Yeah.
So we're on Z, and I used the option -n. It's like a silent thing. It only prints the lines that are operated upon. So when I start with the command that I give into Z is the /beginner and / again, that's a regular expression, which is a word. And then I put P, and it will print any line containing beginner. Insecure with the concept of a terminal. That's fairly right. And then we can do it even more. We can, instead of print, we can do a D for delete. So it will delete any line containing beginner. And you see, it should be here somewhere, beginner, that's the name. And insecure with the concept of a terminal is not there. So if I said head 10 Unix hierarchy, we'll see that the beginner is there, but here it's been deleted. So it's a simple way of deleting lines. But of course, we can do more. We can start substituting. And now it's becoming interesting. We now take, we will use a regular expression. We'll operate on the lines. There is only one line, but the lines with the keyword or the regular expression. Here is it's beginner to make it simple. And then we run the substitute command, and we substitute a dash or a minus with a plus, and we print the line. And we see that we changed from minus plus on this one here. And then we can substitute more. We can substitute insecure with secure. Easy. Then I talked about so much about regular expression. This is something that you just need to spend some time. But as we can see, a very simple regular expression could be just beginner. This is also a regular expression. So we need to match perfectly, but they can have all kinds of wildcards. You can have a match on the previous wildcard, and there is actually, well, there is an end to it, but it doesn't feel like that. So, but you don't need to learn everything. You can just learn a few things and you will still have a very powerful tool. So the regular expression contains a lot of special meta characters. Those you will, if you learn them by heart, it's good, but you don't have to make a cheat sheet. Copy this one or copy some from somewhere else and then just have it handy. Every time you wonder, look this up. So I will not read you through all of this, but we'll have some examples and so on. So a cheat sheet is very good to have. I have a directory in the TXT directory called hints, and there is a lot of hints for the shell and slurm and everything. So yeah, or you can use the web pages that's in here for the cheat sheet. So we touched upon on last time about the characters that are to be escaped, special characters. If we now echo this little here, you'll see we'll get a syntax error because we're not too happy with that one. So in order to send a string through we need to escape it. So here we escape the parentheses. This one is okay. This is safe because the single quotation marks, they are okay. So that will not be opened up by bash. It will be sent directly as it is, piped into sed. And here is where the bash complained because it doesn't like the parent. It looks for any special characters before it behaves on or take action. And the parenthesis is no go. So we need to escape it. We escape a single character with a backslash. And then again, since sed is operating on lines, there is no simple way to escape to do a match or replace a new line. So unfortunately, you need to use another tool if you want to remove the new line command. It's actually a line feed. DOS uses carriage return line feed and Linux uses only line feed. So as will be obvious here, you see we remove the line feed and replace it with a blank using translate characters, TR, and you see you get everything on one line. And it might be that you come across DOS files where you will have to do some more elaborate things like taking away the carriage return and so on, and keep only line feed. So that's about changing characters and matching on line feed. Since sed originates from the editor ed, and that was a line-oriented one, there is of course possible to use line matching. Now we used sed lines up to line 7 and then quit. So we print 7 lines and quit. We could do it even more. We could say 1 to 2 and print. And we can say from line 69 to the end, just to illustrate that almost, and the $sign in sed marks the end of the line. So this is from line 69 until the end, and then print. And I use -m to remove all the lines that are not acted upon. So there's a few things you can do. We can make a stream of things. We can pipe sed into sed again and so on. So we can substitute the same lines with the plus and minus and so on, and we can get this. So there is actually no end to it. So play with it and become fluent. Now we go into more matching. Here I used a regular expression Unix, and I replace with a dot, which is any kind of character that matches easy. Then we can try to match for numbers. You see there is a number 1 here, and here is a number 4. So there are 2 numbers in that file, and we match those. We can select lines that we are interested in. If I press enter now, it will probably fill the whole screen. It does, because I could have done some head or grepping, but you see it acted upon the line containing expert, and it replaced all the S's with all the blanks with nothing. So, and even more fancy matching, we can.
Ole, can I ask a question? So in that in that example that you just printed now, would you use the -n option to not print everything else, only the match?
Yeah, I could use the N.
So then you would just get the line. Okay.
Only the line that we matched upon. Yeah, you could, but I wanted to put it in, print out more, and I piped it through head. I mean, head and tail should be well known. So here you see that I match for 4 dashes. I asked for substitute dash with a plus, and that's what it did. But if I want to substitute all dashes, I use the G for global. Remember, global in grep, it's the G in grep. And then again, if you replace all of them. So you can either take the only one or use global to take all of them. And continue more on matching. There's a lot of interesting things that goes on here. Nothing. So, of course, Unix is capital letters. So we introduce the negation thing. This is like the not operation in Boolean algebra or in digital logic. Then we change from small or minor letters or lowercase to uppercase by saying that this is the opposite of this. That's the uppercase. So we get Unix. And then we continue with numbers. And of course, we can negate the numbers, which will be nothing. So it's easy. Non-digits, hence there is no match. Of course, if I put in an A, it will match because characters are not numbers. So we get a match if we put in that matching not numbers. And then there is the possibility of doing occurrences. I didn't put in head in the the web. So now what does this do? It takes it matched on most of them. So It matched any occurrence with the dash at first one. But then we can say we match two of them. We match only one here, because here is the beginner is one. First of all, there is one here, there's one there, and there is one there. But then we need to match two. Remember head this time. You see, now we have forced to match 2 and 2. So we can try only to match 30. And of course, that doesn't work because there are less than 30 here. So that's how many we want to match. So you can search for or replace or whatever. And we can search for characters, but that will be the same thing. And we can search for overlapping. This is also an interesting one. Here we are searching for 3. And we are searching for 2 consecutive. So we get a match for the 2. That's fine. But then if we change to a number 3, we get no match. Because there is 1 there and 1 there. So that's 2 matches. You see, this is the first 2 here is matching 1. And then those here are second match. And we require 2 matches. And good to go. But there is only 1 match. And there's 1 here. And there is 1 there. And that's 2. But there is no other matches. So that's, if we require 3, it doesn't work. So then it's an interesting one. Remember that we had matching of the first one. We want to match a line 0 doesn't exist. So this is a trick the authors made. They made it so that if you are in a situation where you want to match or change or whatever, the first occurrence of something, then you use line number 0. And then it will only match the first occurrence of that one. And if you say here, it matches here, and then it matches this line, and then it stops. So that's quite nice if you only want to change the first occurrence and only the first. We can do it with numbers. We can make a sequence of numbers and then match only from 1, 0 to 9, which is fine. And then we get 2. But if we use the first one, we only get 1. So if we ask to match first line, we always get 2. If we ask for 0, we only get the first one. This is a bit tricky to remember, but make a cheat sheet and then spend some time to figuring out exactly what's going on. This could be a debate for sitting up at night and drinking beer and discussing how Zen works. But we are not going to do that. And then we'll see that here we only get the first one. If I remove the n, you'll see that it only will match the first two. No, yeah, now it replicates. Of course, it replicates the one that is in pattern space also. So we will get it 2 times. But if you only want to do it once, we need to bring in the -n to not to print the pattern space. Pattern space is the one that matches the line here, and that's the 0 line, and that's being operated upon. That's why we get it 2 times if we omit the n, the -n. Yep. And of course we can use we can ask for a line number 19 and only that one, and that should be like expected. And of course, I put in a longer one here. So using the approximately sign, means that we are starting at 1, and we are doing step 1. That's everyone. Replace has with has and print it out. You'll see we get a lot of still has trouble of typing return after each line of input, etc., etc. But if we take every third line, starting at 1, we'll take every third line. You see we get every third line. So this is a very powerful way of extracting data. Then we can use some of these characters I advise you to put in the cheat sheet. We used to have the preceding match, and you see that we get the match on, we get any character plus, which will do the match on any character, and then in front of the numerical range will match with M1 as it's the preceding one, like the parentheses, and the M where dot matches everything, and we get the 1, and the preceding one is this one, and it's valid because it's any, and M is any character and a match from the preceding one with the plus. Or so we can, yep, we can make it a simpler way. We can say any character plus a letter, a string contains either A or B. So anything, capital A, any character followed by a capital B. That shouldn't be many, but it says, of course, when everything is in capital, we get an A or a B. Here is the first one, or maybe it matches here because N is valid. And then Born Shell, Dennis, and Bill, or B in this way. It's been matched. And then we can even make it simpler. We can use A plus B plus L, knowledgeable, and so on. So there is a fairly comprehensive way of dealing with things. We can matching a preceding one or none at all. Sorry. This is easy because this match 0 or 1 more occurrences. So since there is nothing to match, there's 0 occurrences, which is just printing U and X. Then we print this one. Of course, this is matching on the I, and so this works. Then we can match on several things at the same time by using an OR function, or and don't well, the piping sign is used for both an OR function or a pipe sign. So in this respect, the piping character is used for OR. If you could use an ampersand, it will be an AND function. So this will match for RM or expression. And this is remind that has its first experience with RM. We all have screwed up with RM, but this is a beginner that he first had experience. Had heard of regular expressions, but never seen one. So this is how you can put things together and make quite powerful expressions. And it's possible to combine set commands and several commands. We can say we can take only the terminal and delete, and then use RM and print. Now we deleted the word terminal is not there, but the rest of the 2 lines are matched. So we can put 2 things together, two commands we chain together. So then you can make very long one-liners and quite powerful one-liners. Then we can combine regular expressions. Since this is we can say capital or lowercase letters, A to Z, and numbers. And then we get M4. And remember that the parenthesis 1 isn't matched because it's not part of the set A to Z of the legal lowercase characters. So it only gets 1 match. We have to do something else if we want to have the M1. We need to match also for a bracket or a parenthesis. This is, we put it, the regular expression, we put it into a parenthesis here and there, and then we escape this one. So it will have a match on this, and then it's matching to numbers. And of course we get MV1, the move command. We could also, of course, match where A to Z and then any character and then numbers. That means that it will match this one as any character. And now this one will be part of the lowercase set. This one would be any character, and the number would be part of the set 0 to 1, 0 to 9. And we take one more. Yep. And then this one you have to read yourself. I'm only going to run through the examples. And then there are commands to operate on pattern space. We already touched upon this one. We print the pattern space And that's about what we have dealt with. But this is also going to be part of your cheat sheet probably. But you don't need to remember all of them. You can just put down the one you actually need. And then you remember I said that the arrow up or to use to raise number to the power or hat or whatever you like to call it, and is used for negate as a not operator. But inside the regular expression, it means the beginning of line. And the dollar means end of line. And I could tease you with this, what's happened then. If you match any line that has a beginning and nothing and an end, an empty line. And then we use D to delete, and hence we delete all the empty lines. This a friend of mine was very good at this. During his PhD work, he was bored and he procrastinated and he wrote a Fortran translator, which first of all took away using this one to take away all the blank lines. Then he took away all the comments. And then he started embarking on variables so that they will be like a spreadsheet starting on A, B, C, and so on, and A1, etc., to make the program totally unreadable for anyone. But he didn't finish it off. I still think the last one isn't done yet. Anyway, we have some other interesting thing, translating characters. I'm not sure how much time you will need to use this, but this one will take, this is the command, Y, Yankee. It will have a set of characters here, A, B, and C. And if it touch upon one called A, it will translate it to 1. If it meets something B, it will be translated to 2. So it's a translation table. And you can see here, N1 ME, B is with 3 description, and so on. So it's doable. I'm not sure how often that will be used, but if you have seen it, you'll probably learn how to deal with it.
So you
And
say
then you can do
translate
it
here.
Well, substitute maybe.
Yeah, replace in
It will
some way.
take A into 1, replace A with 1 and B with 2, etc. by position.
What
So
was
B is
the
the second
Y
position, it will
again
take the next string. It's a command. If we scroll up, I'm not sure if I even put in the Y here, but this is one of those, it should be here actually, but I forgot to put it in. But it's one of these commands to operate on pattern space. But it's not listed in the command because the commands are normally put after. So yeah.
So what's the difference if you put S? Because I would have used S/ABC/123. What's the difference between the S and the Y here for the Z command?
I haven't tried. We can. So you want to say
without
S?
not the curly bracket though. I don't know exactly what the curly bracket
No,
does.
yeah.
But
We say 1, 2, 3. No, ABC.
And then G, I guess, for global.
For global. And only those who matched. Nothing. Because if we say grep ABC, there is nothing matching ABC. So the substitute takes looking for this one if it finds ABC.
Yes. So with the Y takes any A, any B, or any C, while the S takes the string ABC. Ah, that's nice.
Yeah.
Thanks.
So if we say it's interesting. Yeah. You see, if we do it like this, if you say Y, it will take 1, 2, 3. But if I say it will set 12D.
Very nice.
So pattern and hold space. This is an interesting one. We don't have time to go to too much, but some web pages like Stack Overflow say that you shouldn't use the hold space. Forget it. Don't do it. But it's an interesting thing because there are something called a hold space that you can take, like the memory button on an old calculator. You press the memory button and you put the line that you are acting upon into the hold space. And then you have the pattern space, which is the line that you actually worked upon. So in this way, there are 3 commands here. One, G and H and print. One G is an address. The first one line, but that means that the command executed will be executed anywhere except the first line. And then you print. So I put it very much, I cut this from somewhere. So if the first line is read and inserted automatically to pattern space. It's not executed, but H copies the first line onto the hold space. Now the second line replaces whatever was in the pattern space, etc. So in principle, you are in fact actually you are printing the file backwards. And then, so you have to read this and try and play with it. But I'll show you, this is a very complicated way of doing cat, the backward way. Instead of tack, you can say cat or tack. Cat will just print it the correct way. Tack will read it backwards. So this is actually doing the same thing. And to really get hold of that, you should look up these here and go through line by line, read it carefully and see what's going on. But it makes for some very, very powerful things. I used it here, but I can't run this because this needs to be on my home terminal. But I wanted to check, let's say you want to run several nodes, ISSH into the machine learning nodes, and then I print the environment, and then I dig out the LMOD version, and then you can see how they play out. So that's an actual command that's being run every day, except that I look for the load instead of LMOD. And then we can make sed commands into executable programs. They are not really executable, but they behave like an executable. So we can remove blanks with a script here, which is fairly familiar. And then we can say this is a script, and then we can call it $1. We can say Unix. We'll see it will cut away all the blank lines. But we can make a script out of this, rm blank. If I say rm blank, you will see that it has X for me, X for users, for group, and X, so it's an executable. So if I say, normally for check for executable, you can say file, ASCII text. So it's a simple, so it can be, if it says binary, then you can just more it or less it. RM blank, this is just like this. I didn't even bother to put in hashbang bin and so on. I just put like this, RM blank, and now comes the beauty with the $1. The $1 is the first argument you give here, and then if I run it, I now created an executable file called RM blank. So any kind of cell script you would like to have, you can make into an executable that will run whatever you like. And we'll continue by adding line numbers if you're ever stuck with programming and you can use sed to print out line number. But as you see, sed is line oriented, so every line number line will also come with line feed. So you see then our line number 1 will be covering 2 lines here. So this is the nature of sed. So maybe sed is not the perfect tool for this one, but it was okay in the times when you print it out on paper. So you could have here on the first line, you will have ample space to write comments with your paper, with your pen. Next one is a Slurm-based thing that I wrote to scan through to files. The Slurm files are simple enough. I clipped out a few things here. It's a starting job. I'm interested in this line here. I want this one first, and then I want the number, how perform number here. And then I wrote this little sed script that will, first of all, it will print MPI tasks. It will put it into hold space. Then it will match the time step. And then I exchange them to write the MPI task first, print, then exchange the whole pattern space again. And then print, so I get the number of MPI tasks and then the time step. So this is just something, it could be done in a simpler way, but I just wanted to see that this is matching. This is the command H. This is the matching time step. And this is exchanging pattern space and hold space. Print the pattern space, exchange again, then print the pattern space. So it's an exercise e-learning about pattern space and hold space. Since we're now done with the sed part, I think it will be okay with a break. So we can go on to sed later, to awk later on.
Yeah, that would be good, Ole. Would you like to look into this notes? So far we have answered it, but if there is anything we can take after break. Shall we have a 10 minutes break and we will come back 2 minutes after the hour?
Yeah.
Okay. Welcome back, Ole. Are you there?
Yeah, I am here.
Okay, great. Let us continue
You
then.
can hear me? Yeah.
Yes, I can, and I want to
Good.
emphasize that please ask your questions or let us know how it is going on the collaborative document. Yes, Ole,
Yeah,
you can continue.
I have it up here. Yeah, so I saw that one. It's been answered fairly well. I mean, Maiken is good at this. Right. We'd start with awk here. Advanced awk. Awk is an acronym for three. It's a three-letter word from the first letter of the three who wrote it.
Ole, before you start, maybe you could. There was an interesting question, number 6. When should I use said awk and what are the differences? I answered by Googling, but
Yeah,
maybe
but
you could say
I
a few
think
words about that.
Said is for the type of things we just went through. If you want to, it's a stream editor. Said stands for stream editor. So instead of having to type the things all over again in VI or Emacs, but VI is very related to ed and sed and E and so on, then said is the thing. It's a stream editor. It process files. Or programming language and or program POSIT. So they are very different things, but they can operate in similar ways. Walk full-fledged programming language, looking a bit like C. So it, as Google says, yeah, Excel, Walk excels at extracting and structured. Yeah. So it's Google is very good here, but I mean, there are some people who are better than me in English who write that in the first place. So yeah, I totally agree with Google here.
Yeah, maybe I can comment something. I use said almost all the time to find and replace Sule.
Yeah.
Yeah, okay, but you continue.
Yeah, so since the basics of awk should be learned from the former lecture, we start with this one. I go straight on the more fancy part. I'm starting awk with a field separator option, the capital F and comma. So comma will now become the normally is space, but it's a comma separated. Comma is the field separator. Then I say that the output field separator and then begin is something that will be done before anything starts. So begin here will be printing these things here. This block here is processed before you start processing lines. So in principle, you could have page upon page of awk code there, processed before anything starts with the lines. Then the new curly bracket is the body of the program, which process lines. It's just printing the number of records and the number of fields. Number of records is mostly number of lines, and number of fields are how many fields there are. And since fields are separated by comma, you have to figure out how many that will be, since it's the comma. So what happened? You see, it prints out line by line. First, it prints the C, and then we'll come on the formatting later. It's using C formatting. And it prints out two characters. First, the field separator, and then the output field separator. And we set the output field separator to semicolon, and the field separator is set here as comma. So it prints out the field separator and the output field separator. And then the first line has only one field because it's there is no comma. And if we Unix hierarchy, you see there are very few commas here. So there could be.
Maybe Ole, you can explain what's inside this print statement here.
Yeah,
the percent C and
I have that later on. I go in detail about about the printf statement, because it's not the, or are you interested in the print statement or the printf?
Just explain a little bit more what line, part by part this walk does. This line does.
Yeah. Print is just printing without formatting. Just print whatever comes. And printf is a C programming language or used in many other languages. Printf is a formatted print. You see here I use C character, but later on will go through some of the formatting in C. But we'll continue with something else. And pattern matching, this is well known from Z. You'll see that if we search for only lines containing dash, which is now, this is between two of these division marks or slashes, there are a regular expression, and we start by doing a regular expression. So only line matching the regular expression will be dealt with. And then print 0. 0, of course, the 0th column doesn't exist, so that means the whole line. So $0 is the whole line. And then you see there are no lines that doesn't contain all the blank lines are gone. There is no lines without the dash here. So that's easy. Then we can do it, say we can use this another regular expression. It's either beginner, and then again the pipe sign, and then novice and beginner, both will match since this is an OR function. We print out only the first column. And we'll get this. Here, beginner and novice, and this is the first column, so we only get this one, and we get this one, and then there is no more matching. We get this. And $1 is the first column. Then we can match for special things. We can match for, we can run the calculator. It's an interesting little piece of code. Calculator. So now we can see we say plus 20, we get 20. And then we can say Z2, raising it to the power of 2. And of course we can say divide by 100, we get 4. So this is a very, very simple desktop calculator by using these lines here. You see it is a regular expression matching the beginning of line, and then we escape the plus, so the shell doesn't cope with it. And then we print out the sum, adding it to the second argument, which is the number. Plus 10 adds to 10, minus subtract. So this is a normal calculator, but it's an interesting little thing that you can do. And then this is to make a matrix. This is Fortran style, because I couldn't come up with some way of doing it this simple in awk, or I was too bored to do so, or too lazy. But we consider a matrix like this. This is just to do numerical work. I mean, just to show that Z can also do numerical work. It can do text and numerical. So we type it into Z. Z, of course, can eat both the standard input, and of course it can take it as a file argument. And what happened now? We take the sum of the first column we say sum plus equal. I mean, you add it's not a reduction, but it's summing up. A fused multiply add, but it's not a multiply. It's just a fused sum where you just add up and increase whatever this one is. And then at the end, we introduce yet another keyword here, the end with curly bracket. This is what you actually execute after the last line of input. So this gives 55. And there is, now we use the C. It will be dealt here with how the C processing will, or the C formatting will work. You see here, we pipe it into awk. We start by sum, and then we print it out at the end. Nicely formatted with the 55 comma, and it's also set to Norwegian spelling. That's an interesting one. I said Norwegian, local is Norwegian, so it actually printed it with Norwegian comma. You see here, it's different from my office computer that uses international or English setting. Same here. We take the sum, and then we print some more. We can also use a string here. And then we say the S is for string, F is for float, and we'll come back to the formatting later on. We get 55 again. The column sum is. Then we can do the diagonal. We again start with K equals 1. We print the diagonal, and it executes this block in the beginning. And then we process each line here, and at the end, we print out the sum. And I put the matrix as an input file at the end, not piping it through awk, even though awk is mostly done as a filtering thing, but it also can eat input like this. Then we print the diagonal. And I thought that it was possible to do it easier. And for those of you who are fluent in C, you will, first you print the diagonal, and there is no K equals 1 here because every variable is initiated to 0. So I started here. This line is now the interesting one. I print a decimal, and then before I start operating, before anything is done with K, it's incremented by 1. By putting the plus plus before the K, boring for those of you who know C, but putting the pluses before K increments K, then use the value. So K in the beginning is initialized to 0. Then the first time this gets executed, it's incremented by 1. Then K equals 1 and printed. And the next time it will increment it again before operating. So it will be the same as here. You see, 1, 3, etc. It's the diagonals. Make it easy. Yeah. Variable plus plus and plus plus are C language syntax. So the C language, the awk programming language, is very much very much alike the C programming language. And we can do some calculations. Here we set sum to the number 4 of the matrix, to column number 4. We print out and we get the average is sum divided by number of records. And number of records are the number of lines that we processed. So inside this block here, the average is here, it's calculate, and then the number of fields will be incremented by 1 for each line of input. And then at the end, this one here will be executed. Gives up 5.5. And again, there are even more fancy things that we can do. We can do more computation. We can say, we set k to 1. Here I actually used k equals 1, initialize k, sum, and then I use the old-fashioned way of k equals k plus 1. But here I use plus equals k, just to show that that there is many ways to skin a cat, as I say. I increment c, and then at the end, this line is processed and executed, and we get the string, float, and float. We run, you see the average are 50 and 5. We come to more or less the same again. The sum and average, then we use the k equals 10, same again. And we can even take the square root, because the square and some mathematical functions are built into the awk language, like square root. And we get square root of 10, which is about slightly more than 3. So it exposed that some mathematical functions are available. So it's a full-fledged language. We now can start, we can use, of course, that we saw in set, we can have the same in awk, that you can start processing files that contains a match, and then we start with the match and then end with another match, and the things that are between are processed. So awk2 is a text file, and it contains this. I mean, some of these have numbers after them, so they are two columns. So if we cat this one through here, you'll see it matched. It will start with cat, and it will stop with lion. So cat 1, 2, 3, 4, and stops with lion. Then start with cat and stops with lion. And then we can introduce some more things here. We can put a variable cat, but it will also match on cat, so that's no big deal. And the lion will also match. So a different way of doing a regular expression, just to expose you to see that you can do the same thing here as we did in SED. So it's nothing special. So, and of course we can turn around if we say 1 and 2, of course, this is piece of cake. And we can extract the numbers. Since $2 is the second column, and if there's nothing there, it's 0. So we can sum up the numbers that we have, which is 25. So that brings us over about more on the language itself. Now you've seen some fancy applications or simple applications. Now we see the basics are, this is printf in C. So $C, Charlie is for character, percentage, not dollar, percentage C is for character, percentage S for string, F for float, and D or decimal for integers. And of course, there's a special symbol for new line, \n. And then it's possible to make pattern matching that is interactive and to see what's going on. So this is 0 to 1, 0 to 9 is an integer, A to Z, and here are capital A to lowercase z. So any kind of character and blank lines. But if I recall correctly, I've made this script to also handle floating point numbers. So if I now say hello, that's a string. 373. It's an integer. Blank line. And now 1.2. It's a float. It should say integer. Okay. It matches both of them. Anyway, of course, the numbers I should have.
Can you show the program also that you made it?
Yeah, that's what I was about to do.
Okay, great.
Here. I just matched for a number, of course. Yeah, I matched for a number and a dot. Of course, that's a float. Of course, you could put in more floats after here. Could be interesting.
This is a good example because in the shared document there was an asked question: how can you run awk as a script? And this is exactly an example of that.
Yeah. So to filter out the integer match, could put in a number later on. Let's see. We have time to do this. But if it doesn't work on the first try, we'll skip. No, it still matches on integer. Yeah. Anyway, this is just showing that you can use regular expressions and so on to match for type. And then storing, rearrange, and reverse a file. So this is the file. And we run the script called reverse.awk, which is given up here. And we see get the reverse. So this is how to make a script up to it. And I have a more elaborate thing that I wrote many, many years ago to help somebody ask, somebody came up with an assessment or something to calculate grades. So I'm not sure if we bother to go through that. I have it here. It's possible we can run it. Yeah. So this is how it calculates grades and so on, and the percentage of failure and so on. Yeah. So this is just an example to show that you can write fairly large program in awk. I once wrote an awk program that early 2000, so many years back. This is actually quite good research. It should have been published. I scanned through a few gigabytes of MPI program or MPI function calls to look for the MPI size, package size or message size. And I wrote a long awk script, but it took 24 hours to process the gigabytes of data. Then somebody rewrote it to C, and it took a couple of hours. Awk is not the fastest thing in the world, but it's not meant to be. It's a language to do jobs like this. So if it's very high, if it takes too long, then it need to be rewritten. But you see, the syntax is very much close to C. For and L. For loops are normal for loops that you expect them to be, not iterative loops that you have in other languages. Tests are exact start, beginning and end. So it's fairly like C. So I wrote a script, when will my Slurm job start? This is number 2. This is just to see that you can use sed to process and so on. I take S control, show job, and the job number. I can't run this. I don't log into any of the systems, so this one you have to copy and do yourself. But I'll explain what's happening. I run S control, show jobs, and with my job number, you need to have a valid number or this will fail. Then I pipe it into awk. I start processing at start time. And if it's unknown, I just exit. I split up the months. I get the substrings here, and then I use numerical things of dealing with things. Maybe it's not the most safe. If anyone changes the format, it will break. Then I use switch D to check. And I'll arrive at a tentative job start. So this is a little script that you could have running and checking when my Slurm job will start. And then if I run it here, I'll arrive. I have some people try to get into this meeting room. I am. Yeah, okay. Silent again. And you can see the job will start at this time here, 3rd of February. But remember, this is tentative. That's why I put in the tentative here, because Slurm might start you later or say, oh. And if you want to turn this into an executable script, you just put this on top, and the rest is the same. And you have to give it permission X to start. And now I did a mistake. It should be a more sensible name, because rev is the running the reverse. So, and this is how I showed that you could make the grades that we already showed. But you should by now have learned to make it into an executable that looks like a seemingly executable. So here's a mistake. It should be something like, when will my job start, or something. But that you can figure out yourself. And of course, here is what I show you using grades and grades data. We show how that worked. But then I decided upon, maybe we should actually try to do some actual real serious programming. I wrote a script that could take a matrix. This is probably more Fortran or Python food or NumPy to LU decomposition matrix. But anyway, it's a nice example that see that it's a real programming language. I take the matrix that we've seen before, and we decompose it. So we decompose the matrix to become upper and lower. And LU decomposition matrix is a lot of for loops, LU decompose, NALU, and so on. So it's a lot of for loop, but that works fine. And of course, there are some tricks here in C that you can have assigned or conditional assignment. So if I equals J, then it 1, else 2, and so on. So, but this is quite common in C to use conditional assignment. So a fairly elaborate program that can be written to fix this, to run this LU decompositions, and we can try to. And you see the first lines here, user bin environment -s and awk. So this will launch awk from more or less any place if awk is not on its correct place. So this is safer than just saying bin awk or something. Of course, you can figure out where awk is, user bin awk. But if you are unsure, user bin env and then awk. That will get the correct awk. So we now say lu.awk. Of course, we need to be not in the right directory. And the matrix. And it will run. LU decomposition matrix. So that leaves time to go through some things I put together for trying to use the tools in Slurm. And we'll start by saying that most of you are familiar with using Bash as the scripting language for Slurm, but any language that has hash as a comment sign can be used to run, to make Bash scripts. So Julia is a good candidate. Python likewise, but I did Julia here. So user bin and Julia, it launches Julia. SBatch job name, Bash is just an SBatch command, which is not read by Julia, and then Julia is executing print line, hello world. So, but for the majority, it's Bash script is, but for many more elaborate Bash scripts or run script for Slurm, Python is used. And then it wasn't meant to be a Slurm introduction, but I put in a little piece here because it goes hand in hand with some Bash and awk and so on, Bash, awk, and sed. These are the one that we actually want you to set. So show commands -x, exit on error -e, and -u, so that error on onset variables. Especially this one could be nice if you RM and haven't set RM and then you are unlucky that you have // or something or slash, it will start removing everything. So to set this in your Bash script is nice. Of course, user limit is another one. ulimit -s unlimited. It should be set, but sometimes it's not. But then we go on to dealing with files. These are the one that we covered slightly before, that you can replace input with output, increasing log numbers. We are my number here, my file 1, 2, 3. And then we say that we want to increase, the next one should be number 4. Then we have a small script that can do this for us here. It uses some fancy small scripting, and play with it yourself. Then timestamping a file, if you want to have a timestamp on your file. DTG is a military expression for Datotidsgruppe in Norwegian Daytime Group. I set it to DTG to, and then I use ISO standard for it. And then I get to this one, 250106 1020 and time zone +1. But that might not be correct enough, so I can say seconds, then I get 10, 21, 17 and time zone +1. You can get away with the time zone. You can use only local. You can use this one and cut using the delimiter plus. This is another way of doing it. I'm not sure if you covered cut, but you can learn about yourself what cut can do, man-cat or cut. Then there is a couple of other way of getting the number, like here, $F, and $X to get the simpler timestamp. So for even more control, there are many format fields. So you can have it whatever you like so that you can put a timestamp on your file. And you can also see that there is no blanks here and only legal characters. So all this is a legal file name. So that's good. But this one can spend some time to figure out which format you prefer, and you can have it more or less exactly as you like. So you just append Daytime Group at the end, and you receive my program like this. So you have out, and you have a very nice timestamp. Then this is some more tricks that you can put in your Slurm file. This is, you run through course 32, 64, etc. Then you run through all these programs, and you run for OMP in course, and you run the program. So this is also what you can, but this is more shell programming than Åke said. But that brings us over to some practical examples. There was some request because people showed up for this training to learn more about Slurm, so we included a little bit of Slurm. Common issues with input and output files, we've seen before. Now comes some cool stuff, making a unique, almost file extension. If you echo $, which is the PID of your current shell, and also a process if it's that, then you can use this one to get a fairly unique timestamp. So the file will be appended with the PID number, and there are very few PID numbers. The PID number is unique. If you wait or run your computer for a very, very long time, this PID number can come again because it wraps. So it's not totally unique, but it's unique enough that all the people I talk to tend to rely on the PID number to have a unique file. And of course, there are a way of dealing with to remove them, and with some type of regular expression in the square brackets again, if you want to get rid of or remove the file. So like this, instead of doing stars, which is not safe. So yeah, be careful to use as strict rules as possible when you are removing files. And then some some more interesting stuff to see, look for files, slurm, A to U, and so on, and more fancy use of regular expression also, but the ls doesn't really eat regular expression per se. It is a subset. And then, of course, when the PID can in some way wrap, so in order to make a totally unique stamp, somebody might come up with some ideas that it's not perfect, but it's close to as close as you can get. Let's say you have the unique hierarchy. We take the MD5 sum of it, call it MD5, print it, and we arrive at this number here. So we can copy the Unix hierarchy into this one and get it timestamped where this long, and we get it stamped as this one. So we are sure that this file is fairly unique, because the MD5 sum doesn't really happen twice. But of course, as a friend of mine called out, that if the file has 0 length, 2 files have 0 length, or they contain nothing, they will have the same MD5 sum. So there is nothing that it's either true, 100% true, or etc. So if the file is empty, the checksum could be equal.
Maybe you could say one word. What is an MD5 sum, in case somebody doesn't know that?
It's in short, it's a checksum, like your personal number or the KID number when you pay bills. They just add up all the numbers and then do something. You take the mod or whatever, then you end up with a checksum.
Just to add it.
Tversum in Norwegian.
Yeah, of course. Just to add it, when you have a data, if you have this checksum and you have moving data from one part to other, it's always nice to check the data integrity. That's what we do with the checksum. We check this checksum if the data is correct. If data is corrupted, you will not get the right checksum when you check it.
Yeah.
So did I make a use case here?
Yeah, you did. Then we already covered when we rushed learn drop start. And then for those of you who are doing programming in Fortran, I covered this last time, but this is an interesting thing, because if you launch GCC 13 or whatever, then cpath is set, but it's set to contain colon here. And Fortran is not happy with that, so you need to have it in this format. And this is the magic expression to convert from cpath. So you can just program gfortran and use this one. It will be right. And it goes into a makefile. So yeah, and then sometimes you have a lot of Slurm output files. I normally don't give them any number. I just use Slurm and then a running number. And I want to look on the latest one. So I can say more or less, and using this, that will give you the last file. And then processing, I showed you that before, that you could do SED with the timings and get the MPI tasks and the timestamping. And then you couple that with a little bit of awk, and you use this simple one-liner in awk and sort it. I also introduce you to the sort command that can sort numbers for you, N for numerical, K for column, K1, the first one. Here I sort them 72, 80, 96, 288, 40, 96 scores, and the corresponding performance numbers. So that covers about it.
Yeah, and on that note, Ole, there was a question 12, which says, if I want to see which time step my job failed, how can I use sed or awk for that?
I'm not sure if I understand the
Time
question.
step or time stamp?
Yeah, because then if your job failed, Slurm will, of course, give the correct timestamp at the end of the Slurm file when it failed.
Oh, yeah, the time step or time step. Yeah, probably it is timestamp. That's what I typed answer.
Yeah.
Or
Do you expect
yeah, good comment, Michael. Maybe time step when you have these log files, you could check it on the logs files which time step that it stopped. If you
Yeah, the
run on
Slurm
log.
log file will contain when the job stopped.
Yeah.
Question number 13 is, and the answer is yes, but how much? I mean, for many users, the knowledge that these tools exist and that they can do something like such and such that take 2 minutes to convey, that's enough, because I know that such a tool exists. I've seen it. I don't know how it works. I don't know how to do it, but I've seen it demonstrated. So I know it's possible to do. And that's enough knowledge to get you started. I've seen somebody did that. It's called SED, but I have no idea what the regular expression is, but it looked exactly what I need. Can you help me? Yes, of course, this is this and this. And here is an example. So we have a few more minutes. I need to go to for lunch at
Yeah,
12, but we have some time still, so no problem.
Yeah, you can ask questions on the collaborative document as well as I just want to say that we are collecting feedback each of the event. So if you have any feedback, one good thing or many good things that we should improve next time, please go ahead and put your comments there. Thank you everyone for joining us during this training. I hope you had a good experience. At least you know you can do many things with SED and awk and utilize in your future work. Thank you so much, Ule. That I know that you were very busy and you are in a hotel giving this training. Thank you for your time to preparing this course material and giving this today. And also Maikin and Espen, thank you so much for helping, answering questions and testing this SED and all on Mac, and which I haven't done it. And give the notes there. Thank you. And